Welcome, space detectives. Let's dive right into an explainer about a cosmic mystery that honestly has some of the smartest scientists in the entire world totally scratching their heads. We're going to look at some amazing clues from deep space to try and figure out exactly what is going on out there in the dark.
So imagine you were looking up at the beautiful night sky. Everything seems perfectly peaceful, right? Well, out there, way beyond what our eyes can actually see, there is a star that is literally breaking all the known rules of space. It's seemingly hitting the brakes and slowing down when, logically, it should be speeding up. So what exactly happens when a star spins the wrong way or behaves exactly the opposite of what all the textbooks tell us? Let's find out.
Section 1. The Great Cosmic Star Dance.
Okay, to understand this giant mystery, we first need to travel far, far out into space to observe a pretty spectacular cosmic dance between two very, very different partners. You see, in space, stars sometimes come in pairs, which we call a binary star system. On one side, we've got our giant star. It's huge, puffy, filled with tons of gas, and it's slowly losing its material. But on the other side, we have the tiny neutron star. Now, do not let its size fool you for a second. Even though it's tiny, it is super dense. I mean, imagine squishing an entire mountain into a tiny marble. Because it's so incredibly heavy and dense, it spins insanely fast and uses its massive gravity to pull in the gas from its giant partner. Basically, the big star is just tossing its gas right over to its tiny dance partner.
Section 2. What is an accretion disk?
Right, so before we uncover the big anomaly, the clue that totally surprised the scientists, we really need to understand the main piece of evidence at our scientific crime scene. When the tiny neutron star pulls in all that gas from the giant star, the gas doesn't just fall straight down. Since everything out there is spinning, that gas actually forms a giant swirling ring. Think of a cosmic donut made entirely of hot glowing gas. Or picture how water swirls around a drain right before going down. Space detectives actually call this swirling donut an accretion disk. It just spins and spins around the tiny star before finally being swallowed up whole. Now, the absolutely crucial point here is understanding the normal rules of space. Usually, it goes a little something like this. The gas forms our swirling accretion disk donut. As it swirls, the gas carries energy and movement with it, something scientists call momentum. Then, the tiny neutron star swallows that moving gas. And because the gas is moving so incredibly fast, it acts like a gentle push, making the neutron star spin faster, and faster, and faster over its entire lifetime. That was the golden rule. Well, until now.
Section 3. Space detectives on the case.
But recently, our space detectives over at NASA's Goddard Space Flight Center noticed something that turned this old rule completely upside down. Lead researcher Demos Kazanes and his amazing team carefully sifted through an incredible 18 years of data. 18 years! They used special X-ray telescopes, which basically let them see invisible light coming from space. They were looking at a starry neighborhood called the Small Magellanic Cloud, just searching for any clues about how these tiny neutron stars were actually behaving.
And what they discovered in that data was absolutely shocking. We just talked about how the golden rule is that these stars should always be speeding up, right? Well, the data showed that exactly 50%, half of these neutron stars were speeding up, but the other 50% were actually slowing down. They were literally hitting the brakes. This was a massive, massive twist in our cosmic mystery. This brilliantly illustrates how scientists actually think. Demos Kazanes looked at this clue and said, the two distributions are really quite similar. This suggests that the processes leading to spin up and spin down might be the same processes. Okay, let me translate that into space detective terms for you. Because the stars were slowing down at the exact same rate that the others were speeding up, it couldn't just be some random accident. The exact same action, swallowing that gas, must somehow be causing both things to happen. Section 4. The spinning dancer's secret. So, we've got a giant question on our hands. How in the universe can swallowing gas make a star speed up sometimes, but hit the brakes and slow down other times? Well, the answer is actually so simple and so cool. Think of a spinning dancer, or maybe just imagine you're spinning on a merry-go-round at the playground. The star's spinning super fast in one direction. Normally, the gas hits it from behind, pushing it to go even faster. But what if the gas from the cosmic donut flows backwards? When that backwards flowing gas hits the star, it pushes directly against the spin. It's exactly like if your friend gently pushed the merry-go-round in the opposite direction you were turning. What happens? You slow down, of course.
That gas wrapping around the star the wrong way is acting as a giant cosmic brake. And just like that, our amazing space detectives completely rewrote the science books. As this explainer shows us, the old rule that neutron stars speed up forever has now become the brand new rule. Neutron stars can actually hit the brakes and change direction. If that gas wraps around them the wrong way, they just slow right down.
But wait, the case isn't completely closed just yet. Good science always leads to more fun questions, right? As other incredible scientists like Tim Kelman and Anne Archibald point out, this discovery leaves us with some big remaining mysteries. Like, how exactly does that gas flip backwards in the first place? And as Tim Kelman wonders, how does this whole messy process change the character of that big puffy companion star that's losing all its gas? Also, Anne Archibald smartly points out that we have to keep an open mind. Are there other secret ways these tiny stars could be slowing down? The universe is a very, very big place, after all.
Section 5. Become a space detective.
The case of the backwards spinning stars just proves that even the smartest scientists in the world are still finding completely unexpected surprises out there in our universe. We definitely don't know everything yet. So, my fellow space detectives, this is exactly where you come in. There is an entire universe out there filled with swirling donuts of gas, dancing stars, and amazing secrets just waiting to be uncovered by looking through space telescopes. Keep looking up, stay curious, and always, always ask big questions, because the universe is literally full of puzzles waiting for a new space detective like you to solve them. So what cosmic mystery will you solve next?